Hello guys, Assalamu alaikum. Today we will talk about push based queue versus pull based queue. So this is a system design topic and you may find it interesting. So at first we will talk about what is a queue, then we will talk about what is actually a push based queue and what is actually a pull based queue, why are the different, then we may see some real life examples, then we will see that why do I really need a push based queue and which type of scenarios do I really need a pull based queue, like the differences in usage in terms of scenarios. Then we can slowly go into more topics, right? Okay, so why do we need a queue actually? In a distributed environment, often multiple applications interact with each other. For example, there is one application and another application, and they talk to each other with the help of another third party. So let's say here is the third party, and this application is sending messages here, and the third party is sending application to this application. So with the help of this third party, in microservice architecture, so many applications can talk to each other, like this way it goes on and on. So this is basically the queue concept. And we see many type of tools or softwares used for queue. Let's say you know about RabbitMQ, which is a very popular queue used in different projects. Then there is Kafka. In Amazon there is Amazon SNS, Amazon SQS, which is Amazon Simple Notification Service, Simple Queue Service. Then same for Azure, you will find Azure Service Bus. Like every cloud provider is providing a queue in their environment. So among all of these queues, like all of the providers, all of the softwares, if all these are divided into two categories, we can segment, like these are the pull based queue and these are the push based queue. So before going into that topic, we will talk about only what is a push based queue and what is a pull based queue. Think about it this way, that what is actually a pull, when does a pull happen and when does a push happen. Let's say there is a door and there is a person. If the person wants to pull the door, he just moves his hand, then he holds it, then he pulls it. So pull happens like this. At first you reach, you grab and you come back. And what is a push? Let's say this is a person and this is a person, this is just throwing. Like it is not going and taking, it is just throwing. So this throwing thing is pull, like push based architecture, right? So how does this push and pull, door pulling and ball throwing relate to our software engineering world? If you think about a REST API call, what happens? Here is a let's say here is a back end and here is a front end. And the front end is every time sending a HTTP request, and the HTTP request is reaching the server, getting the response, and the response is coming back to client. So if we think that a HTTP request is actually similar to the door pulling thing, the front end is sending a request, response is getting prepared in the API and again coming back to front end. So if we think that this is what happening in HTTP request, also long polling, if you know about long polling, one application is constantly hitting another application at a certain interval. It can be 5 minutes. Like this application is telling this application, give me the latest data every 5 minutes. Every 5 minutes it can be an infinite for loop. So this is similar to the pull based architecture. And then what is the push based architecture? The very most basic example would be WebSocket. When we establish a real-time connection in between two applications, whenever there is a new data, it just throws. Like this application don't need to come here and take the data. It just throws and throws and throws. For example, real-time notification, real-time chat application, you don't request the server constantly giving you data. This is same for webhooks. So how does this thing relate to our queues in the distributed environment? Like we were talking about Kafka, RabbitMQ a minute ago. If you closely study, you will see that actually Kafka, RabbitMQ, they are not competitors. They are doing business in their different market. Like RabbitMQ is actually a push based queue and Kafka is actually a pull based queue. So whenever we search in Google the difference between RabbitMQ and Kafka, we have to understand that these are not competitors. Like these are doing their business in their own way. They are providing a separate customer base. They are targeting a separate customer base, separate use case. Like this, RabbitMQ is not replacing Kafka, Kafka is not replacing RabbitMQ. So in which type of scenarios do we need RabbitMQ, and in which type of scenarios do we need Kafka? Like both can be used either way, but which is more appropriate when? We need to understand it, right? So let's say you are using Pathao, Uber, and you are finding a driver from your customer app. You are finding a driver, you need to go from point A to point B. And whenever any driver accepts your ride, the driver wants to take you, he accepts it, and you instantly get a notification that driver accepted, driver is coming. So in this type of scenarios, we can think that a push-based architecture would be better. Like let's say this is a customer app and this is a driver app. So whenever a driver has accepted an ride request, a message is sent from driver app to RabbitMQ, and RabbitMQ instantly pushes the notification to customer app. Customer don't ask RabbitMQ every second that what is the latest status, what is the latest status. No, customer app sits idle, driver app pushes the new status in the RabbitMQ, and RabbitMQ instantly pushes it to customer. So RabbitMQ is instantly pushing new update to customer application whenever there is a new message. So we can say that if there is a driver mobile application and a customer mobile application and a RabbitMQ in between, this notification coming to customer device when a driver has accepted a ride, we can use RabbitMQ here. No, I am not telling I have used it. I have not built any scalable real-time ride-sharing app. I am talking from a hypothetical point of view that yes, this is possible to build, right? Then we have to think that in which type of scenario this can be a problem. Before going into Kafka, before going into pool-based architecture, I want to discuss one scenario with you where you understand that what is the problem with this push-based architecture. Let's say whenever a RabbitMQ pushes a message back, the customer application needs to do something with the message. So it is consuming the RAM of the customer mobile app, right? So let's say the driver application has pushed 100 messages to RabbitMQ in 100, let's say driver app is pushing a new message to RabbitMQ every millisecond. So what will RabbitMQ do? RabbitMQ will throw the 100 messages to customer mobile app in 100 millisecond. So we get one message every millisecond, which is a very burden for the mobile app, because I don't want my mobile app to remain busy every millisecond or even in less than millisecond, because my phone will die. My phone's RAM will consume too much memory, and it will get bloated, and my phone may result in very poor performance, right? I don't want it. So whenever we face such a scenario that we don't want the RabbitMQ to instantly push message whenever it has a message, it is a problem for me. We want to control that. I only want you to push message when I am free. So this is what Kafka gives, which is the pool-based architecture. So how it works? Let's say this is the driver app, this is the customer app, and this is the Kafka. So whenever driver app is constantly pulling messages, whenever the driver app is constantly pushing message to Kafka, Kafka is not instantly sending that to customer app. Kafka will not send 100 message in 100 millisecond. If driver app sends 100 message to Kafka in 100 millisecond, rather the customer app will define that when I need message. If the customer app says don't give me new message before 100 millisecond, and it does a long polling under the hood. So whenever the driver app is sending one message every millisecond to the Kafka, but Kafka is not sending it every millisecond. Rather, the customer app is defining, give me latest messages in a 100 millisecond time gap. So this is a long polling happening in between the customer app which is the subscriber, and the Kafka, which is the queue here, which is the message broker here. So let's say front customer app is asking Kafka every 100 millisecond, is there new messages, is there new messages, and maybe driver app has sent 1000 message in 1 second, but customer app will only pull it when it wants. This is how it ensures that my customer's mobile application's RAM or memory will not be blotted. So, and it pulls message in bulk, it don't pull message one by one. Like in Kafka, you can specify at maximum how many messages can it pull. Let's say if there are too many messages, millions of messages every minute, Kafka is pulling maximum, let's say 100 message every second. This way Kafka is controlling. So if we recap what we talked about, that in RabbitMQ what was happening, what is the default behavior of RabbitMQ? Driver application is sending that I have accepted write request message to RabbitMQ, and RabbitMQ is instantly pushing the message to customer mobile app, and customer is getting notification. But what happens in Kafka? Customer application has sent a wrong long polling, which can be in milliseconds, 100 milliseconds. So the customer app is constantly asking Kafka that is there any new message every 100 millisecond. So every 100 millisecond the customer app is going to Kafka, pulling all the new messages in bulk and coming back again 100 and processing, and after the processing is done, it again goes after the next, after 100 millisecond, that are there new messages, it again grabs let's say 500 to 1000 message and it pulls back. This way it continues. So now the most weird question may arise, why would we ever need long polling? Like, is there any real life use case that we need long polling? Let's say in a driver app we want to see that in which path the driver is moving. Let's say this is the path of Google Map, and the driver is coming to from source destination to source to destination. So the driver's bike or motorcycle is its location is changing every second, its location is changing every millisecond. So the driver app is constantly changing its location and it going into this YXYZ path. So what if we want to store all the coordinates, that in which second the driver was in which position in the Google Map? We want to track in which millisecond the driver was in which position in Google Map. So every millisecond, if the driver app sends one message to Kafka that my current location is this, and sorry, if the driver app sends its current location every millisecond to RabbitMQ, and if every millisecond RabbitMQ pushes one message to the customer mobile that here is the location of your driver, then the customer's mobile application will die. It cannot process thousands of messages every second, it is not possible. So instead, what is better suited in such case? Driver app may push its new status update to Kafka every millisecond, every nanosecond. We don't care about that. The customer app depends on its capacity, depends on how much message it can process at a time, or how frequently can it process without getting died. The customer will set the long polling interval, like the customer app may say, give me the latest location of the driver every millisecond, or if the customer's mobile app is more slower, it can set the polling interval to more. This way the customer's app defines that when I am allowing Kafka to send messages. Another great example of Kafka would be log storing, like the driver app is sending its location to Kafka and Kafka is sending the latest location to customer. It is not enough. I also want to store that what in the last 1 hour, in the last 24 hours, in which paths the driver moved, in which of the roads he went. Because if there is an accident, if a driver has a road accident, if a driver has lost, if a driver is out of track, no one can contact him, then we want to check in which of the paths was he going in the last 1 hour. So we want to store. So for this storing, we also every second, every millisecond, we want to take the driver's location to Kafka and store it somewhere from Kafka. This is how we ensure that if any accident happens, we have already stored all the previous locations of the driver. So we have talked about two scenarios. One is when I am pushing message to RabbitMQ and RabbitMQ is instantly pushing it to the consumer, and another scenario we talked about Kafka, that is driver app is constantly sending its location updates every millisecond or even multiple times in a millisecond, and the driver app and the Kafka is only and the consumer, which is a customer application, is only pulling the messages with its own stated long pulling interval, so the memory don't die, right? So I think this video has already been so long, it's 15-minute crossed, so let's keep it up to this. Thank you.